Today's lesson is about theorems, about roots. I'm going to explain to you that a root and x-intercept and a solution are all the same. Okay, roots, solutions, x-intercepts, they're all the same. Okay. There are times in which we're going to have a hard time factoring polynomials to figure out our roots. So we have to use a theorem. Think about what are the possible answers for a polynomial, and that's called the rational root theorem. And I'm going to briefly kind of explain how to find the possible roots. It's actually a ratio of the factors of your constant. In this case, it's 10. And you know the factors of 10 are 1, 2, 5, and 10. And it's going to be the ratio of the factors of 10 over the factors of 21, which is 1, 3, 7, and 21. So if I had to show you the ratio, it would look something like this. It would be 1 plus or minus 1 plus or minus 2 plus or minus 5 plus or minus 10, and then what you'd have to do is, it's a ratio, so you're dividing, and it's going to be plus or minus 1 plus or minus 3 plus or minus 7 plus or minus 21. And you notice that 2/3 is there. There's 2/3. And you notice that 5/7 are there. And those are the roots. Those are the x-intercepts, and they're also the solutions. So these names, or these vocabulary words, mean the same. Roots, solutions, x-intercepts have the same meaning. Another vocabulary word that I forgot that I should have listed, it's also zero. So we're going to do an example, and we have a cubic polynomial, for example a, and it's asking for what are the rational roots of 2x cubed minus x squared plus 2x plus 5. So we're going to list the possible roots, and you notice that the factors, we got to find the factors of 5, which is our constant term, over the factors of the leading term, which is 2. And you notice that the factors of 5 are going to be plus or minus 1, plus or minus 5. And the factors of our leading coefficient, which is 2, is plus or minus 1, plus or minus 2. And it's a ratio. So if I wanted to know the possible rational roots, it's going to be 1 plus or minus 1, because it's 1 divided by 1, which gives you 1. And then you also have 1 over 2, so it's plus or minus 1/2. You also have 5 divided by 1, which is plus or minus 5. And you also have plus or minus 5 over 2. Remember that for it to be a root, or for it to be a 0, the y value has to be 0, right? So for it to be a 0, we know that the y value has to equal 0. So what we need to do is we need to use synthetic division, and our goal is to figure out which of the roots is going to give us a remainder of 0. Because if it's a remainder of 0, then I know that it is a factor. Okay, so I'm going to try 1 and I'm going to go ahead and use synthetic division. Now, I'm going to try it. Right now, it's 2x cubed minus x squared plus 2x plus 5. I'm going to try 1. So we're going to see if 1 is our root. So we list the coefficients. 2, negative 1, 2, 5. And you notice it's in standard form. We're not missing any exponent. We have 3, 2, and 1. Bring down the 2. 1 times 2 is 2. Negative 1 plus 2 gives you 1. 1 times 1 is 1. 2 plus 1 is 3. 1 times 3 is 3, is 8. So 1 will not be a factor. So now let's try negative 1. Maybe negative 1 is a factor or it's a root. So we have 2, negative 1, 2, 5. And remember we want a remainder of 0. Negative 1 times 2 is negative 2. Negative 1 plus negative 2 is negative 3. Negative 1 times negative 3 is 3. 2 plus 3 is 5. Negative 1 times 5 is negative 5. 5 minus 5 is 0. So since our remainder is 0, then I know that x equal negative 1 is a root. So now I need to know what are the remaining roots. Well, I know that I've already found one of them, so my new polynomial is 2x squared minus 3x plus 5 equal 0. Zeros using the quadratic formula. So you have x equals negative b plus or minus square root b squared minus 4 times ac divided by 2a. So I'm going to go ahead and move it up just slightly. So we have x equals, we know that a is 2, we know that b is negative 3, and we know that c is 5. So we have a negative, and then we have a negative 3, so it's 3, plus or minus square root negative 3 squared minus 4 times 2 times 5 divided by 2 times 2. So we have x equals 3 plus or minus square root 9 minus 4 times 2 is 8. 8 times 5 is 40 divided by 4. And you notice that we're going to have an imaginary number. So let me move this a little bit again. So we have x equals 3 plus or minus square root of negative 31 divided by 4. So the two remaining roots are going to be 3 plus or minus I square root of 31 divided by 4. And this is a complex conjugate. Remember what I told you last lesson, that these will come in pairs. So our root is imaginary. These two are imaginary, and then we had one that was real. So altogether we have 3 zeros, 3 roots, and 3 x-intercepts. They all mean the same. Now, if I were to graph this, to check this, these imaginary solutions would not be seen. So I'm going to go ahead and go to the menu, press new. So I really want you to do this with me. So go to your calculator and press graph, and let's go ahead and type in the polynomial. So you have 2x cubed minus x squared plus 2x plus 5, and you notice it's cubic, we notice that the end behavior is going to be down and then up. I'm going to press enter. So it's down and then up, and you notice here is the only 0, which is occurs at -1. Okay, so you notice the others are going to be imaginary. Example B, the zeros for 15x cubed minus 32x squared plus 3x plus 2. I went ahead and used these steps so you can understand what is the process. Number one, you need to understand that the possible roots are going to be the ratio of 2, the factors of 2, to the factors of 15. The constant term, which is 2, is going to be plus or minus 1 and plus or minus 2. The leading coefficient factors are going to be 1, 3, 5, and 15. So what you have to do now is divide, and that's what they did. So we have plus and minus 1 is a possibility. Plus or minus 2 is another possibility. And then you have fractions. So we have to test, or we have to guess which root is, which number could possibly be a root. So we're going to try 2, and we're going to use a synthetic division. And if 2 is a 0, then our remainder will be 0. And we start with our leading coefficient, so you have 15, negative 32, 3, 2. You're going to go ahead and drop the 15. You multiply 2 times 15, which is 30. It's going to be negative 32 plus 30 gives you negative 2. 2 times negative 2 is negative 4. 3 plus negative 4 is negative 1. 2 times negative 1 is negative 2. 2 plus negative 2 is 0. So we notice that x equals 2 is a 0. And that's where you get that factor, that linear factor x minus 2. And you notice the coefficients are 15, negative 2, and negative 1, which is right here. So that's our remaining 2 zeros or 2 roots. I recommend that you use the quadratic formula. So I'm going to go ahead and write the quadratic formula. We have x equals negative b plus or minus square root b squared minus 4 times ac divided by 2a. And we know that a is going to be 15. We know that b is going to be negative 2. And we know that c is going to be negative 1. So we have x equals 2, since b is negative 2, plus or minus square root. We have negative 2 squared minus 4 times 15 times negative 1 divided by 2 times a, so it's 2 times 15. So we have x equals 2 plus or minus square root. So I'm going to go ahead and evaluate the denominator. 2 times 15 is 30. Negative 2 squared is 4. 4 times 15 is 60 times negative 1 times negative 4 gives you plus 60. I'm going to go ahead and simplify. I'm going to move this over just a little bit. So we have 2 plus or minus square root 4 plus 60 is 64 divided by 30 equals 2 plus or minus square root of 64 is 8 divided by 30. So our two answers are going to be 2 plus 8, which is 10, divided by 30. So one of them is going to be 10 over 30, which is equal to 1/3. And the other root will be 2 minus 8. And I'm running out of room, so I'm going to do it up here. We have 2 minus 8 divided by 30. So x equals negative 6 over 30, so x equals negative 1/5. So the roots, or the zeros, are x equals 2, x equals 1/3, and we have x equals negative 1/5. Now, you could check graphically. You can also check using the calculator, which I'm going to do right here. And I'm going to substitute into the polynomial, and if I get 0, then I know it's a 0. So I'm going to go to the calculator, and I'm going to type in 15 parentheses 1/3, and I'm going to go ahead and raise it to the third power. Let me just delete this. 1/3, and then I'm going to raise it to the third power, minus 32 parentheses 1/3, and I'm going to raise it to the second power, plus 3 times 1/3 plus 2, and I should get 0, and I do get 0. Now I'm going to go ahead and check negative 1/5, and let me just circle my zeros. Okay. So those are the zeros. And so I'm going to type in 15 parentheses negative 1/5. And I'm going to raise it to the third power, minus 32 parentheses negative 1/5 squared plus 3 times negative 1/5, and then plus 2. And I should get 0. And I do. So those are all my zeros.